Hi all, today we are solving LeetCode problem number 1411, number of ways to paint n cross 3 grid. So you are given a grid of size n cross 3 and you want to paint each cell of the grid with exactly one of the three colors, red, yellow or green, while making sure that no two adjacent cells have the same color, that is no two cells that share vertical or horizontal sides have the same color. So what exactly this line mean? So let us understand this with an example. So let us assume there are three colors. So let the colors be A, B and C. And you have n cross 3 grid, and for time being consider n as 1. So it's 1 cross 3 grid, and you have three places to fill with all these colors, and the condition is no two cells should share a same color. So these two cells share a same color, which is A. So this is a wrong combination. So this is horizontally it is sharing the same color, and in the case of vertical also it should not share the same color. So this is the condition which it there they have given is. So based on this, for 1 cross 3 you will have two patterns. So you can fill by A, B, A as one pattern, and you can also fill the color by A, B and C by the other pattern. So totally you have two patterns to fill in the color, and in case of 2 cross 3 it should be so A, B, C. If I am filling with A, B, C, this should be B, this can be A and this can be B. So this is a valid one. In case of if you are filling this, I'm sorry, BAC, and if it is BCA, so here it's the adjacent colors are same, so this is not a valid combination. So with this, the ask is given n number of rows of grid, return the number of ways you can paint this grid. As the answer may grow large, the now answer must be computed by modulo 10 power 9 plus 1. So what is the ask? So basically the ask is to return the number of ways which we could paint the cells actually. So with this particular pattern we can come to we can find that this is a common word for dynamic programming. So here we have written the number of ways. So this is a common word for dynamic programming, and also we paint each of the grid with exactly three colors, right? That is also one more observation here, and there is no two adjacent in vertical and horizontal. So basically the next grid it depends on the previous one. So which means the n depends on n minus 1th grid combination. So with this we can come to a conclusion that this problem can be solved using dynamic programming. So with having this in mind, let us run through the first example. So as we said, we have two patterns, which is ABC and ABA. So this is in case of row 1, and if you fill this pattern with color, so for ABA if you fill these things with the colors, you will get red, yellow, red, and red, green, red, and green, yellow, green, green, red, green. So you get 6 combination for ABA, and for ABC my bad, RYG, RGY. So here also you get 6 combination. So basically with this we can say that for 1 cross n you have 2 patterns, and each pattern have 6 combination. So use with this, summing up these two, you get 12 possible combination, which is the answer given here. So for one you are getting 12 as the output. So this is the base case which you have to consider. So the base case is, let me draw this with the help of decision I'm sorry recursive tree, because we are solving with dynamic programming, and the base case is for row 1 we, for a particular pattern we are returning 6. So for let us consider the function definition as DFS row and pattern, and we have two pattern. Let ABA be named as 0 and ABC as 1. So for row 1 DFS 1 comma patterns, so you have two basically. So let me have it as row 1 DFS 1 comma pattern 0 and DFS 1 comma pattern 1, so which is 6 and 6, and summing up you are getting 12 as the output, and we are returning 12 as the output. So let us understand this with one more example. Example 2, we have 2 cross 3 grid. So for 2 cross 3 grid we can have row 2, and we have two patterns. So DFS 2 comma pattern 0 and DFS 2 comma pattern 1, and this will have DFS 1 comma pattern 0 and DFS 1 comma pattern 1. So we totally have 4 paths here. So the output will be summation of all 4 paths. So what will be the answer? Like we have we have a little we have to understand here that you have to go with the combination. So you have 6 combinations here, and 6 here, and 6 here, and 6 here. So similarly, we have to have the possible combination which will satisfy the vertical and horizontal row and column condition. So based on that, you can assume this pattern 0 as ABA, right? ABA, and this is ABC, and this is ABA, and this is ABC. ABC. So this combination will be multiplied with this combination, and you choose only the right and the legit combination out of it. So this ABA has ABA, AB, ACA, BCB, BAB, CAC, CBA, and ABA. So when we combine with these two together to form the 2 cross 3 matrix or 2 cross 3 grid, this and this condition fails because there is 2a, the vertical condition fails here, and similarly the vertical condition fails here, and there is a middle b, and here also the condition fails. So you have only possible 3 combinations here, so this will be 3 here. And similarly, when you have uh, for ABC, or let me explain for ABA with ABC. So for ABC, this will not be a possible combination because the vertical rule gets broken here, and similarly this the vertical rule failed, and the same CAB also failed, and CAC also failed, and you will have only 2 combination for ABC, and you will have 2 combination here, and I'm sorry, this should not come here, this should be 3 here and 2 here. Similarly, the same thing will happen here, and you will have 2 combination here and 2 combination here. So with all this, you can find a pattern here. So by what is the observation? For if the pattern is 0, so we are having 2 recursive call here, which is DFS, where it is going to the next row, so that we have to reduce the row by 1, row minus 1, comma, pattern as 0, and you have to multiply this with 3 and add with DFS row minus 1, comma, pattern 1 multiplied with 2. So in the else part, which means patterns matches 1, the DFS will be row minus 1 with 2 and row minus 1 with 2. So this is the recursive pattern you could find based on the example 2, which I have drawn with the help of recursion tree. So with all this in mind, let us go ahead and code. So for this problem, the time complexity will be order of n, because how many DFS calls we have made? It is 2n actually. So for row number 1, row is 1, we have 2 recursion call, so it's 2n, so which we are representing as big O of n. And similarly the space complexity is also big O of n. So let's go ahead and code it. So the answer must be returned with computing modulo 10 power 9 plus 7. So because of that, mod is equal to 10 power 9 plus 7, and we use memo for reducing the time complexity and reducing the DFS calls, recursive calls. So and key will be, we are storing row and pattern, and value will be the answer, the possible combination which we are returning. So let's define the function DFS and row pattern. So as discussed, the base case will be when the row is equal to 1, we have to return 6 as, because each combination returns 6 possible outcomes. So if row equal to 1, return 6, and check for DFS calls in memo. So if row comma pattern is found in map, which is memo, return it. And now we are getting into the core recursive logic. So pattern, so we have to return the answer and we have to update the answer as the value in memo. So I'm using a variable to store the answer, and equal to. So in each iteration the row get decrement by 1 because we start from the higher row, like in the example as you can see that we start from row 2 and we end in row 1. So because of that, row minus 1 in each recursive call, and the pattern for pattern 0, which is the ABA pattern, you have to multiply with 3 because of in the example 2 you could see that there is 3 possible outcomes is only possible there. Those are the valid outcomes, not the possible one, they are the valid outcomes. So because of that we should multiply with 3 and rest everything with 2. So DFS row minus 1 with 2. So here this changes actually. There is only 2 patterns, 2 combination valid, so hence this should be multiplied with 2, and now update in memo. Row, and this should be stored by by, this should be computed by modulo operation, modulo with mod, and you have to return the answer as the result of this df recursive call. So return memo of row pattern. And now you have to call the recursive call based on the input whichever is given. So the input is n, will be the row will be given as an input. You have to pass this in the recursive call and execute them. So you have two possibilities based on the two patterns available. So because of that, you will have two recursive calls will be returned as the to determine the output. So return, and you have to return that by doing computing this with modulo mod. So dfs, and here the row is n, so n comma 0 plus dfs n comma 1. So hopefully this should work. Let's go ahead and submit it. As you can see, this is, oh, let's submit it once again. Okay, so this is pretty efficient solution. Thank you.